The universe, with all its galaxies, stars, planets, and mysteries, has long inspired humanity to ask one fundamental question: where did it all begin? Among the many attempts to answer this, the Big Bang theory stands as the most widely accepted scientific explanation for the origin and evolution of the cosmos. According to this theory, the universe began about 13.8 billion years ago from a state of unimaginable density and temperature, often described as a singularity. From this beginning, space itself expanded, carrying matter and energy outward, leading to the formation of everything we see today. Far from being just a guess, the Big Bang theory is supported by extensive evidence, including the expansion of the universe, the faint glow of cosmic microwave background radiation, and the observed abundance of light elements. Yet it is also more than a scientific model. It is a story of human curiosity, scientific revolutions, and the quest to understand existence itself. Human beings have always wondered about the beginning of the cosmos. Ancient civilizations developed myths and stories to explain the heavens. In Babylonian tradition, the universe was said to have formed from a cosmic battle of gods, while Hindu philosophy described cycles of creation and destruction stretching into infinity. Greek thinkers such as Aristotle argued that the universe was eternal, unchanging, and geocentric, with Earth at its center. For centuries, this idea was reinforced by religious and philosophical traditions, shaping the way people thought about creation. Yet, as time passed and scientific reasoning developed, these views began to shift. The Renaissance and the scientific revolution introduced a new way of thinking, one that sought natural explanations instead of divine myths. Copernicus placed the sun at the center of the solar system, Kepler mapped planetary orbits, and Galileo, with his telescope, showed that Earth was not unique but part of a much larger system. By the 17th century, Isaac Newton introduced the laws of motion and gravity, which described the cosmos as an interconnected system governed by natural forces. Newton's universe seemed infinite and timeless, but his equations also hinted at an instability. If gravity pulled on everything, how could the universe remain static forever? That question would linger for centuries. The real revolution in cosmology began in the early 20th century with Albert Einstein's general theory of relativity, published in 1915. Einstein proposed that space and time were not separate entities but part of a single fabric called spacetime, which could curve under the influence of mass and energy. This new understanding allowed scientists to model the universe as a whole. When Einstein applied his equations, he found that the universe should either expand or contract. Uncomfortable with this idea, he added a cosmological constant to keep it static. However, others began to explore the possibility that the universe might be dynamic. One of these was Georges Lemaitre, a Belgian priest and physicist, who in 1927 proposed that the universe had begun from what he called a primeval atom or a cosmic egg, which exploded and expanded to form galaxies. At the time, Einstein rejected the idea, believing the universe was eternal, but evidence was soon to prove otherwise. In 1929, Edwin Hubble made a groundbreaking discovery while studying distant galaxies. He noticed that the light from these galaxies was shifted toward the red end of the spectrum, a phenomenon known as redshift. More importantly, the farther away the galaxy, the greater the redshift. This meant that galaxies were moving away from us, and not only that, but the entire universe was expanding. Hubble's law provided direct evidence that the universe had not always been the way it is today. If it is expanding now, then in the past it must have been smaller and denser, leading naturally to the conclusion of a beginning point. Lemaitre's idea suddenly gained credibility, and the foundation of the Big Bang theory was set. The term Big Bang was actually coined by Fred Hoyle, a supporter of the rival steady-state theory, which proposed that the universe was eternal and maintained its density by creating new matter as it expanded. Hoyle used the phrase Big Bang mockingly in a radio broadcast in 1949, but ironically the name stuck and became the accepted label for the theory. For decades the two models competed, but the Big Bang had a decisive advantage. It made predictions that could be tested. Among them was the idea that if the universe began in a hot, dense state, there should be leftover radiation from that early period, spread evenly across the cosmos. This prediction was spectacularly confirmed in 1965, when Arno Penzias and Robert Wilson accidentally discovered the cosmic microwave background (CMB) radiation. While working on a radio antenna in New Jersey, they detected a faint, uniform noise that came from every direction in the sky. At first, they thought it was interference or even bird droppings inside the antenna, but after cleaning and testing, the signal remained. It was soon recognized as the very afterglow of the Big Bang, cooled over billions of years to just a few degrees above absolute zero. The discovery of the CMB provided overwhelming support for the Big Bang theory and earned the two scientists a Nobel Prize. From that moment, the Big Bang became the dominant explanation of the universe's origin. The Big Bang is not described as an explosion in space, but rather an expansion of space itself. At time zero, the universe was concentrated in an extremely hot and dense point, perhaps smaller than an atom. In the first fraction of a second, known as the Planck epoch, physics as we know it breaks down, and our current theories cannot fully explain what happened. Shortly after, a period of rapid inflation occurred, where the universe expanded exponentially, smoothing out irregularities. As it cooled, energy converted into particles such as quarks, electrons, and neutrinos. Quarks combined to form protons and neutrons, and within minutes the first nuclei of hydrogen, helium, and trace amounts of lithium were created in a process called nucleosynthesis. For the next 380,000 years, the universe remained a hot plasma of charged particles and photons. Only after it cooled enough for electrons to combine with nuclei to form neutral atoms did light begin to travel freely. That light is what we now detect as the CMB. Over millions and billions of years, gravity pulled matter together, forming stars, galaxies, and clusters. The story of cosmic evolution from the first atoms to the complex structures we observe today is all rooted in the framework of the Big Bang. Evidence for the Big Bang comes from multiple independent sources. First, the expansion of the universe, discovered by Hubble and confirmed countless times since, demonstrates that the universe is not static but dynamic. Second, the existence of the CMB provides a direct glimpse into the early universe, a fossilized relic of its hot, dense origin. Third, the observed abundance of light elements matches perfectly with predictions from Big Bang nucleosynthesis. Scientists can calculate how much hydrogen, helium, and lithium should have formed in the first few minutes, and those numbers align with astronomical observations. These three pillars, expansion, CMB, and elemental abundance, form the core evidence that makes the Big Bang so powerful. Of course, no theory goes unchallenged. Alternatives such as the steady-state theory, oscillating universe models, or multiverse hypotheses have been proposed. The steady-state model collapsed after the discovery of the CMB, while cyclic models suggest the universe undergoes endless expansions and contractions. The idea of a multiverse, where our universe is just one of many, remains speculative, but is sometimes considered an extension of inflationary theory. Despite these debates, the Big Bang remains unmatched in explanatory power and observational support. The Big Bang theory not only explains how the universe began but also raises profound questions about its future. Will the universe expand forever in a big freeze, where galaxies drift apart and stars burn out, leaving a cold, dark cosmos? Will dark energy accelerate the expansion to the point of a big rip, where even atoms are torn apart? Or will gravity one day halt expansion and reverse it into a big crunch? Current evidence points toward endless expansion, but the ultimate fate remains uncertain. Equally intriguing are the philosophical questions the theory poses. If time and space began with the Big Bang, what does it mean to ask what happened before? Some scientists argue that the concept of before is meaningless because time itself was created in that moment. Others explore possibilities like quantum fluctuations, higher dimensions, or eternal inflation spawning multiple universes. These questions blur the line between science and philosophy, showing that cosmology is not just about physics but also about the deepest mysteries of existence. Modern technology continues to refine our understanding. Telescopes like the Hubble Space Telescope and the James Webb Space Telescope peer deeper into space, effectively looking back in time to witness the birth of galaxies. Experiments in particle physics attempt to recreate conditions similar to those just after the Big Bang, while satellites like COBE, WMAP, and Planck have mapped the CMB with exquisite precision, revealing tiny fluctuations that became the seeds of galaxies. Each discovery confirms, adjusts, or extends the Big Bang model, showing that science is an ever-evolving journey. In conclusion, the Big Bang theory is far more than a theory in the casual sense. It is a comprehensive scientific framework supported by multiple lines of evidence. It tells us that the universe had a beginning, that it has been evolving for billions of years, and that it will continue to change long after we are gone. It connects the smallest particles to the largest structures, linking physics, astronomy, and philosophy in one grand narrative. While questions remain and mysteries abound, the Big Bang stands as one of humanity's greatest intellectual achievements. It is not just the story of the cosmos, it is our story, for the atoms in our bodies were forged in stars that exist only because of the events that began with that first, extraordinary moment.